All right, in about 1 minute, we're going to start our next presentation here at noon in the exhibitor forum. Please join us. We're going to start in about 1 minute.
Okay.
Yeah,
All right.
that's right.
So welcome everybody. I'm here today with Michael Muncy, VP of Semiconductor Industry at Siemens.
Yep, and I'm here with Vishal Mundra, VP of Solutions at Perforce.
Welcome, Michael. So we are here today to talk about the newly announced strategic partnership.
Absolutely, yeah.
Perforce and Siemens.
Yep,
So
that's why you get two of us in the exhibitor. It should be the exhibitors forum.
Exactly.
Yep. So this is a really exciting time, right? You know, because we're seeing a lot of changes in the industry. And you know, Siemens being the company focusing in digital twins and digital threads, you know, with the changes we're seeing, we need to complete some of them, and this partnership is perfect.
Exactly. And so over the course of the last couple of years, we've been working together, and then we just formalized the partnership the end of last quarter. And now Perforce plus Siemens is going to be a out-of-the-box solution for many tools, where Perforce tools like Perforce and IPLM can work together with the Siemens tools, like Solido, you know, and other tools coming down the pipe, out-of-the-box integrations, right?
Yep.
So that's the vision.
Absolutely.
Okay.
And you know, really what's bringing here is that we see a paradigm shift, right? And what we talk about here now is the idea of software-defined products. And we use the term inside of Siemens, software-defined, silicon-enabled, right? Because software needs to run on something and it runs on silicon, right? And I have my trusty demo here. You know, it could be a car also, but it's easier to carry this, right? You know, anybody who has a mobile phone, if you happen to have one of this one, you update to the latest iOS, you actually have a better phone today than you did when you bought it.
Right.
And the reason why is that decisions were made when this was being decided that things inside of it would be software upgradable. So it's not just the fact that it runs software and you interact with its software, the product itself is software defined. So the latest update made the microphones better because it had better DSP algorithms. It made the camera better because of better DSP algorithms. It made the battery last longer because it optimized the power profile of the chip. And it actually made the life of the battery last longer because they optimized the way that they charge the battery management system, right? So decisions had to be made up front that allowed this to happen. And when we talk about things being software defined, that's what we mean. You have to make decisions up front to allow for the actual hardware that powers the software to be able to be upgraded. And you know, it's true of this. It's true of cars when we talk about the software-defined vehicle.
Yeah.
But there's differences, right? If this thing has a problem running the software and it locks up, it's an inconvenience. If you're driving your car down the highway at 80 miles an hour and the software locks up,
That's a little bit more challenging.
that's a little bit more problem, right? And so we need to think about now how we do design, how we do verification, and account for the fact that decisions are made up front, there are requirements, there's verification that has to happen, mapping back to requirements to tie this all together.
Right. And to that point, when we talk about traceability of all of this, right? So as you said, you have very high pressure and high reliability requirements for some environments. And those environments, you may have to trace back faults, you may have to trace back problems that you see in the field, and you need to be able to drive that down, not just through a manufacturing process, but all the way to design.
Absolutely.
And so that's where the digital thread comes in.
Yeah.
That's where we're talking about connecting not just the top level PLM, but going down into the design, perhaps down to the file level changes,
Yep.
and be able to expose that in an easy, simple fashion.
Yep.
Right? And so Siemens obviously has multiple tools that work and do a great job in their particular aspect, what they're working on, whether it's testing, whether it is design enablement, whether it is the whole PLM system itself.
Yep.
But putting all of this together and making sure that you connect that back into actual design files, actual IP management.
Yep.
That's where the collaboration really shines.
Yeah, absolutely. And it's not just the files, right? It's the data that goes along with that.
Exactly.
And when you think about a product design right now, and we could probably jump to the next slide here, right? When you think about the product design, you have software, you got semiconductors, you got the EE systems that tie it all together. You also got mechanical aspects of it. You talk about a lot of different data, a lot of different metadata, yes. And it all needs to come together. And it's not just a chip, it could be a 3D IC, right? And how do you handle all the data with the different 3D ICs? Yeah. Coming from, I would love it if everybody used only Siemens EDA and only used Siemens PLM solutions, right? That's not the world we work in, right? And it's other vendors that all of this has to come together. So you have to tie the files together with the metadata all together.
And let me take one step further, right? We're talking about IPs, chips, assembled together, even 3D ICs, but now start putting them together in boards, right?
Yep.
And having mechanical systems on top of that, right?
Yep.
And software stacks. Now there are so many systems that interact together,
Yep.
that work together, and they can all be verified independently by various tools.
Yep.
But how do you put all of this together so that the system itself has seen verification cycles,
right?
Has seen a platform where they've all been brought together, they've all been verified, so that they work together not just independently, but in concert with each other.
Absolutely.
That's a huge challenge.
Yeah.
And Siemens has tools that solve some of these problems. There are other vendors that solve other problems.
Yep.
So there's a variety of vendors, but there's a variety of systems,
yep.
And there's a variety of metadata that all has to be managed. Right?
Yeah.
So we're looking towards a world where you have, starting with the software-defined product, leading to a situation where you have multiple systems that have to work together into the foreseeable future,
right.
Not just when you're testing it.
Right.
So all of this leads to what we're talking about as a collaboration.
Right, and another example I like to talk about is the data center. Right, I often talk about it goes from the chip to the package to the board to the blade to the rack to the data center. And when you're building a data center, right, somebody has to worry about the infrastructure. And now think about this: the person that's providing the chilled water for the HVAC systems, the actual electrical infrastructure to drive the electricity for all of it, the way you cool these racks, right? You could start tracing this back now all the way down through the chain, and eventually you get down to the actual semiconductor and software that's running, right? So decisions are often made at an infrastructure level, and they're often done, we say, by their best guess, best estimates, the way they've done things in the past. Well, it's not always the case that doing things in the past is the best way of doing things, right? The idea that now, because you could start looking at granularity further and further, and the fact that you could actually do verification at a chip and software level together, use that to drive, power analysis, come up with a power profile, which then could go into the larger system level modeling tools to do, for example, heat dissipation and thermal modeling of the whole system, right? But we're talking about a lot of data, right?
Yes.
And if you're going to make decisions, you can actually optimize things, right? But you have to make sure you're mapping, the right IP, the right data, the right metadata, the right vectors, and tying this all together, yes, to be able to make these accurate decisions.
Exactly. So it comes directly into what we're talking about, which is you need all these tools that are doing their particular function to have a common platform that they can sit on top of and easily exchange data.
Yep.
Right? They have a place where you can deposit the metadata, manage all of that metadata, and the next tool down the flow can pick up the same metadata.
Yep.
And you don't have to invent individual collaborations between a couple of tools here and there to make this happen. What if there was this platform on which the tools can sit, and then they can deposit their metadata and exchange their metadata in a seamless manner.
Absolutely.
And that's what this collaboration brings.
And that's what completes a digital thread, right? And being able to do all this together.
Yeah.
So, it's more than just that. We could build upon this, right? There's other things that we could start doing when we have this platform with all this data available to us, right? So, do you want to talk a little bit about that?
Sure. People may have heard of AI. I don't know.
Yeah, I think so. There's a couple AI companies around there.
Yeah. So specifically, looking forward, we have design data in a platform. We have metadata. We have tool-generated workflows. We have these workflows connected to each other. That generates a pool of information that can then be used to train AI models.
Yep.
And that's the vision as well, which is, it's not just enough to say, hey, here's your design, or here's a series of designs. Just go figure out, train a data model. You need to associate with that design and all the various versions of the design, all the metadata generated by workflows and tools that need to then be part of that data lake or AI data lake, as well as connected to each other. You need to know that on this particular version of a block, we ran all of these tools, these were the results, and if you can tie all of that together and put that into an AI data lake, you suddenly increase the power of being able to train your AI models far greater than it was only on data or some disconnected metadata, right? So this connection is a very, very critical piece of what we need going forward to train your AI data models.
Absolutely. And we've invested heavily at Siemens in AI, right? Starting with our Slido products, we're probably one of the first companies out there to actually adopt machine language learning to actually improve verification. This was long before anybody knew what a LLM was about, right? And we've just announced our EDA AI platform, which we're embedding in all of our technology, right? But the key here again is, how do you access all of that data, right? It's one thing to look at things locally and optimize at one level, but then you want to start looking at things globally, and how do you optimize globally? And again, going back to what I said, it's great if everybody used Siemens EDA, but that's not going to be the case. And we're going to be looking at bringing in data from other tools. And IPLM is the perfect way to capture that, because that data is now tied to the IP within the database. So the IPLM starts playing a very key role in that underlying data lake. And then we could start looking at decisions that were made up front early in design. How did those affect ENR, right? How did certain test vectors we ran, right, ultimately affect the amount of time it took us to eventually close on functional coverage, right? But then, we have to start extending that even further, right? Because if we're talking about just about design, but there's a whole life cycle we talk about here. So you have NPI, right? So decisions are made early on, what goes into software and what goes into hardware, kind of what we talked about, the software-defined product. And are there better ways to make those decisions, right, to optimize that? And then how do we resource it when we actually go to build it and actually design and verification process? And then so we have the whole NPI process and how that feeds into design. And now we have manufacturing, right? One of the big questions here is, how can we make designs that are more manufacturable, right? The time to volume is going to be critical, right? So decisions that are made up front also start tying into the back end, right? And fundamentally, this data lake has to be connected throughout the entire life cycle. So it's life cycle data, it's NPI data, it's manufacturing data, it's design and verification data that all need
and all tied together with the right versions, with the right metadata that sits on top of it. So the connection between the metadata that's generated by a tool and the design that was used to generate that metadata is actually critically important.
Yes.
Because you could have data lakes of just the design data, or you could have data lakes of metadata. That disconnected, pools of data does not lead to what we really want to achieve here, which is being able to broaden the scope of what's possible, right? Which is to say that, we made these decisions early on, and look where it led us.
Yes.
Right? Was that the right thing to do or not? That kind of analysis cannot be done unless you're tying the exact metadata generated by tool workflows to the exact versions of the design, so that the training is complete. Right? And so that's that's a key role, and then that's what we're heading towards, and that's the vision for the AI data lake that we're talking about.
So let me ask you this. We started off talking about software-defined products, right? And now we've been spending a lot of time talking about the actual semiconductors, right? Well, there's a software aspect as well here, right?
Yes.
So is it equally important to start tying software and the hardware design together in this
Right,
case?
and so we've seen this happen all the time where there are effectively siloed teams.
Yeah.
There's the software designers and then there's the hardware designers. Typically hardware leads software by, I don't know, months, weeks, whatever it is.
Yeah.
And then the software people who are building the stack or the drivers, the various components, software components, are waiting to get hardware drops, right? Now, these siloed teams, the way they've been working, and we've seen this across many customers, is that there's really no organic connection between these two teams.
Yep.
The hardware team is running at its own pace, the software team is coming behind and trying to figure out which version of the hardware should we be using to test our stack, to build our stack on. By putting all of this hardware as well as software components as IPs in IPLM, you can actually tie them together much more closely. You can track which version of the software stack was tested on which version of the hardware BOM.
Yep.
And then you can also release the whole thing as a platform, and you can keep going up the chain, right? So having a single platform where the data storage is not a hurdle, right? And the actual components themselves are not hurdles. They can all live together and interact with each other in the same platform is an essential part of what we can do to scale this out.
Yep. So we're talking about a lot of data here right now. And everybody's concerned about IP and IP protection, but there's probably the same thing's true about their data as well and the metadata, right? So within IPLM, is there a way for us to handle the actual IP governance and data governance and protection?
Yeah, so we've been working with various customers to build out multiple things here, right? IP governance and rules. That's a huge part of what we do, which is you can set, just to start with the basics, in IPLM you define an IP, which can then have metadata properties, which include things like who's allowed to see it. That's the most basic thing, right? Who has access to this data is where you start. And then you can geofence your IPs as well. You can say this particular IP is only visible to users within this particular geography. Even if the same user goes to a different geography, you can no longer see that IP, right? So you're starting to put together a baseline of what it means to have protections. But then you can go further. And you can say, I'm going to put a governance module around these IPs, and they can only change at a certain things have to happen before you can declare this IP as usable in a certain set of products. Or you can put in rules that say, no one shall ever use this IP in this kind of a product, right? So you can start partitioning data in automatic ways so that you have a built-in mechanism which does not allow you to make mistakes or stumble over things that you're not supposed to do.
Right.
And that leads to data protection. That leads to IP protection.
Yep.
Right? So building that, within IPLM, we have all of these frameworks that when utilized correctly, will make your job much easier when it comes to managing IPs, managing the data in the IPs, as well as the IPs themselves.
Yep. And then I think the other thing, we all talked about the software-defined vehicle, and we need to talk about things like functional safety, right?
Yes.
And the key here is that it's all about traceability and going from requirements through design into verification and then tying those results back, right?
Yeah.
And going through the audit process. We spend a lot of time with our automotive customers, documenting all of this, right? But again, there's a whole data explosion, and not all the data is relevant, right? So I guess another key thing here is, mapping the right data through that thread to be able to achieve compliance.
Right, so tying requirements to, let's say, verification is something that can be done in isolation, but unless you bring the design data into that equation, you're basically tying effectively some set of requirements to something that got tested, but you do not know what was it that you tested, right?
Yep.
So to complete that V model for automotive safety, you need to take requirements, tie them to design, and then tie verification on top of it, so that any change in requirements can be traced to a change in the design, can then be traced to whether that particular change was verified or not, right? And that is very critical because you have to go through design to get to verification. You can't just tie requirements to verification and say that we did everything right, we verified everything. But if you do not tie it to design, you do not know what version of the design was it that you actually did the verification on, right? So looking at that, the tying requirements to specific design versions, and then tying verification results back onto those same design versions, that is where you complete the thread.
Yeah.
That's where traceability becomes something that the system can give you rather than you scrambling through spreadsheets and documents and other sources of unstructured data to kind of generate these reports.
Yep.
Right? So we have practices and we have customers using our tools to build this traceable flow, requirements to design to verification, and be able to generate these compliance documents or audit trails quite easily.
Yep. And this is why I'm really excited about the partnership, right? Siemens, our three, pillars have always been, the comprehensive digital twin, openness in customization, right? And the fact that when we talk about the software-defined product, to have that comprehensive digital twin, it's about bringing software into the equation, bringing the semiconductors into the equation, and being able to build out this total digital twin, and be able to thread all the information through there.
Together.
And this is what the partnership actually brings to us.
Yes, the platform is now ready to build out that connectivity, right?
Yeah.
And we have talked to many teams inside Siemens, and we hear this palpable excitement about the fact that they don't have to go and invent custom ways to talk to other tools, right?
Yep.
That's one of the biggest missing pieces is this large portfolio of tools that Siemens has.
Yep.
And all these tools need to interact with each other in some shape or form, and you don't have to go and invent custom ways to do it. You have a platform on which all of these tools can interact, and you can tie requirements, verification, cross-check, other tools, Questa,
Yep.
Caliber, all the premier tools that are offered by Siemens can now potentially talk to each other without having to custom, build these interfaces. Because that's a waste of engineering talent, that's a waste of time, and it's also, when you have a third party that is inserted into this flow, how do you make sure that all of these work?
Absolutely, right, yes.
So having an open, REST API-based platform like IPLM, where everybody can talk to the same platform, actually erases and breaks down a lot of these barriers.
Absolutely, and that's the real value that we're bringing here, right?
Exactly.
Focusing in on the actual design and the verification of the product,
Yes.
and not wasting our time on some of the
On
more
building
mundane
custom
tasks. Exactly.
interactions.
Absolutely.
So the first thing that we have already launched is working with the Solido team,
Yep.
Crosscheck and IP Delta,
Yep.
the two tools that made so much sense to work together with. And then we've had a great integration working already.
Yep.
It's in demos at both the Siemens booth, at the Perforce booth, as well as we've been giving demos to various customers.
Exactly. Yeah.
And I'm not kidding you. We do see a lot of excitement in
Yep.
the industry. We've been, basically people have been asking me and you across both Siemens and from customers, like, when can we see this, go further, right? When are we going to see the Caliber integration?
Yep.
When are we going to see the Questa integration?
Yep, and we're always also doing work in the 3D IC front.
3D IC
because
front as
customers come to us. It's great. We use a Siemens Flow, but I'm still taking data in from Cadence. I'm still taking data in from Synopsys. How do we tie all that together? And we're tying that together also
tying that
within
together
Flow.
also, yeah.
And then, like Questa, as you mentioned, next one up down the pike, right? We have Caliber coming up, and it's going to be great to be able to tie this all together.
It's super exciting.
Absolutely excited. So with that, we're open to any questions. If anybody has any questions?
All the tough ones go to him.
That's just it.
All the easy ones come to
They asked us for you to go to the microphone, speak closely.
You can all hear me?
a little bit louder.
Louder? This is good?
Yeah.
Yeah.
Okay, so we now have millions of IPs and somehow they're all connected and we can go from the lower stack to the higher stack. But there's still this human element involved. People need to be able to keep up with the change in there and being aware of what's happening in the system and new versions coming out. What are your thoughts on this human element? How can people keep up with these changes?
Okay. So clearly there's overwhelming amount of data, both just data itself and what you have to pay attention to is scaling, a lot. We can keep talking about notifications and emails and Slack threads and whatever. This is just too much, right? So part of our vision is to look at, are there assistants that can help you do this, right? You can probably, in the near future, maybe build a system where you can sign up to an IP and only be informed with some filtered information, which is relevant to you. And then the system can understand what you're actually working on and give you more or less information based on that, right? So that's a great question. So far, we have not addressed it. We keep talking about, hey, can we notify the user about X or Y or Z? And the number of notifications just keep growing. So
You've generated a follow-up question.
I know.
So yeah, that's kind of the follow-up question. We now look at AI.
Yes.
Is there a place where we can use AI to be more intelligent with notifying people, hey, you're probably interested in
Yes.
this, or hey, this change happened, you should probably look at this. So can we use an AI to filter out the
noise.
the noise and be more focused and help people make the right
Yeah, absolutely, and that's the purpose of AI here is, everybody's worried about AI taking people's jobs. I'm more interested in how AI are going to make people more efficient, right? And that's where some of the values are going to come from this. Already with our EDAI platform, if you get a chance to go up, you can actually see as somebody's interacting and asking questions, the responses become more tailored to the types of questions we're asking, right? So it's, for example, if you're querying about certain types of IP, that it's going to realize that you're probably interested in those IP and maybe related IP as well, right? But there's certain stuff that you're never, right, should be care about, and they'll keep it below the noise level. And that's all about, going through the data and making sure you become much more efficient.
And in addition to that, if you have a true learning system, right, which can learn not just the fact that here's all this information and there's a filter that needs to be put in place, but what is important to you as a person or as a designer or as a manager, that is truly the power of AI, to learn with you and help you become a true assistant that's tailored to your needs, right? I don't think we're there yet from our perspective, but that's a vision that we can definitely shoot towards.
Yep.
So you mentioned requirements, right? So to what extent do you digest the requirements to tie it to design and verification?
So from our perspective, we treat requirements as metadata, which is that we don't actually look at the requirements themselves because we focus more on the management of data, not the interpretation of the data. So our view is you have requirements, right? And you're started to do your design based on a certain set of requirements. So you take a snapshot or a baseline of that requirement and you attach that baseline to the design at the release, at a release of that design. Now the requirements change, your design changes, and again, as soon as you create a new release, you create a new baseline snapshot of the requirements and attach it back, so that you can not only diff requirements among each other, you can figure out what was the baseline of the requirements that were used to design a particular version of your IP. And then if you attach verification results on top of that, now you have a version of the design that can tell you exactly what requirements were used at the time of that design's creation, and what was the verification that happened in addition to that, and that completes the thread.
Okay, thank you.
Yeah.
Any other questions? All right, well, thank you for coming and listening to us. And, please visit the Perforce booth and this Siemens EDA booth upstairs, and we could show you some of this and actually working in action.
Yeah. Thank you.
Thank you.
All right, that concludes our morning sessions. Enjoy your lunch, and we'll meet you back here at 1:45 for the last session with IBM at 1:45. Thank you.